Welcome back to Thinking with Objects, lecture number 6, Enumerations and Error Handling. Before the break, we spoke about the enumerations part. What we have left is the error handling part. So let's get going with that, shall we? Right, so let's take a look on this example here. We want to import java.util.scanner, and we also want to import java.io, so that's input-output.file. Okay, so I'm going to read some data from a file. Public class exception example. Okay, so what's this all about? Well, not a lot actually. Yes, so static public static void main string args, like so, and then we create a scanner. But not like we've usually done it. What we do is scanner equals new scanner, so far so good, but we have, well, the scanner has constructor overloading, which means we can create the scanner in a few different ways. And what we can do is create it with a file instead of the system.in, and then we can give it data.txt, for instance. So that's the path of the file, and since I don't define the specific folders I'm looking for data.txt in, it's going to use my current work directory. So it's going to look for C users vsw desktop dropbox / data.txt if I do something like this. Then what I could do is just use the scanner like I've done before, but now we're going to read from the file instead of from the standard input, which is what the user types. So scanner.next line. So this will print out the first line of that file. Pretty handy, right? But we need to do one more thing. When we work with scanners, we need to close them. This is not, however, what we have done before, and that's because when we make a scanner of the system.in, we're not supposed to close it. It's going to, because we can use it throughout the program, and then it's going to be handled on its own. But when we create other scanners, like in this instance here, when we create a scanner from a file to read the file, then we need to make sure that we close the scanner when we're done. And since we're just going to use this scanner to read one line, I can read more lines, but since I just want to read one line, I'm going to close it as soon as I've done that. Of course, if we want to do more things with the file, read more lines, read more integers, read more boolean, I don't know, then we want to close it when we're done with all of those things. Compile this, and we get an error, and that was expected. So what this is when we create a scanner from a file, it might throw us a file not found exception if it can't find the file itself. And what that means is that an error is occurring and the program will crash. But since the scanner knows that, well, I'm probably going to give you a file not found exception, so you are not allowed to just do this. So you have to make sure that you try to catch it and do something with it. So that means that we have to try and catch it. So what we do is we do try here and enclose all the code that we have that we want to do something with, and then what we do afterwards is type catch. But then we have to define what we want to catch, and what I want to catch is java.io.io exception, which simply means that something went wrong with this input and output, so input-output exception. And what I do then is IO exception, so I type the type there, and then a variable name of that exception. I'm just going to use e system.out.println something went wrong while handling the file. Stack trace can be seen below. So stack trace is basically how we got to that error, what methods we called, what classes we have, what we have initialized, and so on. So how we got there. And if we want to print something like that, we can do e.print stack trace. So you can get information about the errors in a few different ways. I'm not entirely sure what all of they are called, but like get an error message and a short message and whatnot. And one of them are print stack trace. So we have a try here, and we type our code in here that might cause trouble. Then we have a catch here, and what we want to catch is IO exception, and we want to call that E if we do so. So if we catch an exception, we're going to run this code here, and we're going to have the error as E, and therefore we can do E.print stack trace. Sweet. So why this works now, why we don't get any errors, is because the scanner says, well, if you're going to create me from a file, then I might throw a file not found exception. So please make sure that you catch it, but file not found exception is a subclass to IO exception. So that means that if I'm trying to catch any IO exception that do occur, then I can catch any file not found exception as well. So let's run this code now. It's going to print out "I want cake!" exclamation point. The reason why it prints that out is because that's the first line of the file data.txt. However, if I do data2.txt, that file do not exist, I can tell you. So therefore we will get first of all, it's going to say something went wrong while handling the file, stack trace can be seen below, and here's the stack trace that we printed out. A lot of data here, and the only thing that we actually do recognize is probably this line. So at line 9 in exception example, we got an error, and that was when we tried to create a scanner here, as you can see, row number 9 there. But this is the stack trace, so it started down here somewhere, and it just called methods alongside. We got into our main method. In the main method, we tried to create a new scanner, and that's tried to create a file input stream, and I tried to open the file input stream, and when it did so, it didn't work. So there are a lot of information here that you might not want, but it's possible to print that stack trace out. And note that this is not a crash. We didn't crash at all. The program actually went all right and finally just allowed us to continue. So that was just because we wanted to print that out. If I, however, remove that and run it, I will just get something went wrong while handling the file. Stack trace can be seen below. It's going to tell me that I have a stack trace to see, but we're not printing that out. Okay. So that's the first thing. What if we want to do something specific if we actually get a file not found exception? And if we get any other IO exception, then we want to do something else. That seems like a plan. So what we can do is have multiple catches, and we just put them after each other like this. So I'm going to do catch file not found exception. So that's another type of exception, of course. And I need to import that as well, and that's located in the same package, so java.io.file-not-found-exception. And what do I want to do here? Well, I can do anything. I can print a message out. This file was not found. I don't think you know what files you have. So we can just do anything. We can rickroll the person who's running the program because, well, the person did it wrong, or anything. But we can do different things. So if we find a file not found exception, we will run this code. If we find an IO exception, we will run this code. However, a file not found exception, like I said, is also an IO exception. But that won't mean that we run this code. So we will only run this code if we have a file not exception, just because that's the first catch that we managed to catch the error with. So if the exception is of the correct type of the first one, alright, then we run this code and none other. However, if we compile this, we won't get an error, but we will get a warning. And the warning is about, alright, do you really want to do this? Because, you know, the scanner here, that might throw a file not found exception. Okay, that's alright. And you're catching that, that's also alright, which you have to do. But you're catching it with an IO exception here as well. And what it realizes is, well, if the scanner is going to throw a file not found exception, we will find it here, and therefore there's no reason to have this one here. That doesn't mean that we're not supposed to have multiple ones, but that means that it thinks that the only error it expects is already being caught. So therefore it thinks, oh, maybe we don't need this, but maybe we actually do. For instance, if we have int a equals 5, int b equals 0, and then we do int c equals 5, not 5, a divided by b, here we will get another exception being thrown that is, well, I think it's java.io lang.arithmetic exception or something like that, because we're trying to divide by 0. And of course we don't get an error right. You need to try to catch that java.lang.arithmetic exception, because not all things tell us that, oh right, this is probably going to cause a problem, it's probably going to give us an exception. So since it doesn't do that, we don't have to have a catch for that, but it can still happen. So just because it assumes that, well, we're probably not going to have anything here that we haven't caught already, that doesn't mean that that's the case. So maybe we get another type of IO exception, like wrong file format, whatever. I don't know exactly what IO exceptions they are, but that's why it's going to warn us about it, because it thinks that every exception that we can get is already being caught. But that's of course not the case. All the exceptions that we must catch have already been caught. So that's the issue. And of course it's all fine, it's just a warning, it's not action error. So we can run the code now. So if I run it like this, we're going to get this file was not found. I don't, it's supposed to say think you know what files you have, and that's because the file not found exception was found and caught in the first catch, and therefore the second one wasn't run at all. What if, so here we have two different catches, so we run two different codes if we have specific errors here. What if we want to run one specific code for two different types of error or exception? We can do that as well. So I'm going to, oops, I didn't mean to hit compile. I'm going to scroll up here and import another exception here, java.lang for language, I guess, .IllegalStateException. So that means that we're trying to do something when something is in the wrong state. It's not like a person is being in the wrong state in a counter or anything. It doesn't have anything to do with that. But if we want to do that, so we want to do just print out you did something wrong or something like that. Let me see here what I'm. Yeah, okay, yeah. In my notes here, I didn't do anything special. You're doing it wrong, mate, something like that. And that's when we have a file not found exception, or if we have a what was it called, illegal state exception. So now we're piping these two together with this vertical line there. So if we find a file not found exception, we're going to run this code. If we find a illegal state exception, we're going to run this code. So let's compile. We still have that warning, but no errors, and then we can run it. You're doing it wrong, mate, because we're trying to read a file that does not exist. However, if we do it with data there which do exist, it's going to print out I want cake. And then if we try to read something here, after we've closed the scanner, it's going to throw an illegal state exception, because we're trying to read something from the scanner that has been closed. So if we run it now, it's going to say I want cake and you're doing it wrong, mate. Why is that the case? Well, we get a scanner and that's working all right. We found the data.txt, and then what we're trying to do is print out the first line. That went all right as well. It printed out I want cake. We closed the scanner, went all right, but then on the last line here we tried to print something else out from the scanner. So we tried to read the next line after I want cake, and that didn't work. We closed the scanner, and therefore this part here of the catch catched that exception, and therefore we ran this code anyways. So that's why we print out I want cake and you're doing it wrong, while if we had just data2 here, it would fail before it read I want cake, and therefore we would only get you're doing it wrong, mate. Alright, so what more do we have here? Well, we have something that we can add at the end called finally. Phew, finally we're going through that. So what we can do here is define things that we want to be run afterwards, after we've done the try and catch. So if we reach this point in the code here, we might want to run the finally here. If we get an error when we try to create a scanner, we're going to go inside here, and then we want to run this code as well. Why can't we just print our code after the try catch? Because that would be run after the try catch, right? Well, of course, but there are differences, so I'll show you. So when we close the scanner, we need to make sure that we do that if we use a scanner from a file, to make sure that everything is closed, everything is set back where we were, all the resources that we have used is put back, so something else can use them, and so on. But at the moment here, if I try to do something and get an exception after I created the scanner but before I close it, so observe that we have no example of that at the moment. The only different types of errors we have is before we actually manage to create a scanner, if we have a file not found exception, or after we've closed it by trying to do something after it has been closed. But if we do have an error that we can catch in between here, which is it can be anything. It can be a null pointer exception, it can be a divide by zero exception, it can be another scanner that we can't open if we're trying to open multiple files, and so on and so forth. But if that happens, what we will have is a scanner which we haven't closed, which is bad. So what we could do is just close it in all the different catches, but that's just annoying. So what we will do is put that in the finally part. So what I'm going to do is just define the scanner up here, so I can refer to it from without in other blocks, and I'm just giving it the value here instead. And finally, what I'm going to do is to put it in finally. But just to make sure, I'm going to make sure that we actually have a scanner. If something went wrong, so we don't have a scanner, we don't want to get a null pointer exception, and then we close the scanner. And to see that everything works all right, I can do print out closing the scanner like that, and also something here, finally block. There you go. At the moment it's that sometimes happens. I have it in my Dropbox folder, so sometimes when it's syncing it, the Dropbox is using the file at the same time as .java, and then we get an issue like that. And that's a good example actually, because if we don't close our files properly, that will happen a lot. But now it's just happening if they happens to want to access the files at the same time. So I just resaved this file and it worked all right. Okay. So what we have now is a code here that we could put outside the finally and just have it in the end here, because it will just rerun anyways after the all the catches and everything. But if we take a look here, we can run it, and what's going to happen is you're doing it wrong, mate, finally block. So that's because we can't read the file, and therefore we don't get the scanner. We go in here, and we can't close the scanner because we never opened it, so it's totally fine. But if we do data there and run it like so, then it's going to say I want cake, final block, closing the scanner, like so, because, well, the scanner is not null and we make sure to close it afterwards. However, what we can do something else. Why do we actually use the final block? Well, that's to make sure that this actually always happens. We always want to make sure that the scanner has been closed. And what if we want to return something when we get this error? Maybe we want to say, alright, return 5, it means that we got the error code 5. Return false, this method failed. Return, I don't want to do this anymore, a string or something like that. So maybe we want to do that. But in this case, we're not in a specific method that we've written that can return anything. We have a void method. So what I'm just going to do is return here. So we exit the program if we get any of these two types of exceptions, but if we get this exception, we're not going to bother. Then we're just going to print that out and continue. However, even if we want to close the program here, we want to close the scanner if it's open. We know for sure that it's not going to be in this case, because, well, if we get the file not found exception, we're not going to have opened it at all, so there's nothing to close, and we can't get an illegal state exception at the moment. But there are multiple errors, and the code can be much more advanced than just 2 lines here. So we want to close the program, but we want to make sure that the scanner still is being closed as possible. Well, we don't actually have to do anything at all. As you can see here, it's working properly first, but then if we go into the other file, or check the other file called data2.txt and run it, what we'll see is you're doing it wrong, mate, and finally block. What's that? So even though I return to exit out, the method, since I'm inside the finally block, or well, inside a try catch that has a finally block in the end, that code is going to be run just before I return to the method's value, which is, we don't have a value there because it's a void. And just to make sure that that's the case, we can do system.out.println end of times, for instance. And if I hit compile and run it now, I will see you're doing it wrong, mate, and finally block, but I won't see end of times. But if I do data.txt, which is a valid file, so no exceptions will be thrown here, we will get I want cake, final block, closing the scanner, and end of times. So as we can see, even if we break out somehow using return, maybe we're using continue in a loop, breaking out of a loop, yeah, we can do whatever to sort of break out and not run the code in the end here, which is maybe what we want. So when we got an error, we're not going to print out end of times. But even if we got an error and want to return something, get out of here, we still want to make sure that the scanner is closed, and therefore we can have a finally block. And this is actually highly recommended, how you should close scanners that you have to close, and other things that you have to close as well. So if we have a scanner here with the file, then it's recommended to have that in a finally block, so we always make sure that afterwards, even if an error occurred, even if we return after an error, we will make sure that we close the scanner. Okay, so that's not everything. Let's reorganize some things here. So what I want to do is create a private static void read first line, and then I want to do that at a specific path. Okay. But what I add afterwards is a bit weird, peculiar here. So what I'm going to do is add throws file not found exception. Okay, so I added that in the end of the method. Okay, and what I'm going to do then is just add some code here. So I do scanner equals new scanner, you know, new file. So I create a file at that path, or a file object, and then I use that to open the scanner. And finally I do system.out.println, and then I print out the very first line like that, and finally I close the scanner. Okay, so I'm not inside a try catch now, so I'm going to get an error, or wait, what, I'm not. I just get the warning that I had before, which is still this thing here. So why not? Why don't I have to include this in a try catch? And that's of course because I tell it that this method might throw a file not found exception. So I don't have to catch it, because I declare that this method here is going to throw this file not found exception, or it might at least throw a file not found exception. If we remove this, we will get an error, and if we read the error carefully, we will see unreported exception java.io.file not found exception must be caught or declared to be thrown. So this is the same exception we saw in the beginning, but it's not. We don't have to catch it. It's telling us that we must be caught or declared to be thrown, and that's exactly what we do. We declare that we can throw a file not found exception, like so. Right. So what does this mean? Well, it means a few different things. Let's remove this code here, and then we want to read first line. It's in yellow because I had that warning there, so it assumes I'm on that line. So data.txt like so, and I hit compile, and now I actually get a proper error here. Unreported exception java.io.file not found exception must be caught or declared to be thrown. I recognize that one, don't you? So what this means is I have a method called read first line, and it might throw a file not found exception. That means that when I call the read first line, I need to catch that exception. I need to do something with it, otherwise I just have an exception there that is going to cause troubles. So basically what this means is that the constructor of scanner, so when we create a new scanner using a file, that method is declared like this. So it is declared to throw, that it can throw a file not found exception, and that's why we have to bother about it. But if we also declare this method to throw a file not found exception, we don't have to care about it in here. Right. So what do? Well, we do a try, we do a catch, file not found exception, and then we might print something out here. Got an error in the method, or something like that. So why would we do this? We still use a try catch, right? Well, take a look on it like this. If we would have a try catch inside the scanner constructor that does the exact same thing, like we would have a try catch there instead of it throwing a file not found exception, then what would we have? Well, then that would take care of the error it caused itself, and therefore it would just maybe print out, I couldn't open this file. But that's not what we want. Don't want our program to just print couldn't open this file. We want to be able to define ourselves what's supposed to happen. And how do we do that? Well, at the moment we do it like try catch file not found exception. So we print out this got an error in the method. If an error happened and if an exception were thrown, rather than having the scanner do it on our own, or well, this method itself. So that means that we can throw the exception, and we just tell the outside code, I guess you can call it, that this method might throw that, so you will have to take care of it yourself, and that's exactly what we do. Okay, but this is not everything. We want to make sure that we close the scanner even if we have an issue, right? So like we did before. So what you can do is still do it something like this. Okay, like that. Try. Finally. Okay, scanner.close, but we need to make sure that we actually have if scanner is not equals to null. So what we do here is quite simple if you think about it. What we have is a try, so we try to do this, and if an error occurs, we want to find a catch that matches it. We don't find a catch that matches it, and therefore we can't catch it, and therefore it will continue up here and be caught up there instead, because here we have a catch with file not found exception. However, we still have a finally. So after we have run the code, try here, even if we got into trouble and hit an exception, which we would get if we use data 2 like that, then we will still run the finally code and make sure that if we have a scanner, then we close it. So here we have an example where I use try finally just to be able to close the scanner properly. And like I said, this is highly recommended how you should close the scanners properly. But observe, you're not supposed to do that if we create a scanner like we've done before with system.in. Then we're just supposed to leave it open. So we have try finally here. We make sure that we close it if an error occurs, but the actual error is thrown here, and we catch it up there. There you go. So that's everything I'm going to talk about error handling. Actually, there are a few more things that you could learn about. You could make your own exceptions. You can like extend file not found exception and throw your own, like file not found exception, because why not? Like you can make your own exceptions. You extend the existing ones, maybe add some more content to them, and so on. But that's not going to be a part of this. If you're interested in that, you can check the internets. You can just Google it. It's not that tricky. It's just creating new subclasses of other classes, and that's what we've done before. But what I'm going to take a look on now is that surprise that I was talking about, or at least I mentioned. And that's if we click project here, I have something called dragons. Let's click on that one. So what is this? I just opened something, and we can see a lot of different things here. So this is a project in Dr. Java, so you can have projects, and then we organize it a bit better. We have different packages. We have, instead of just having a lot of files open, we organize it as a project. And what this project is something called, well, it's in the folder Dragon Game. And what I have here is about 20 different classes and files. So what happens if I compile and run this? Let's see. Oh, there we go. This is, well, more advanced than what we've done so far, right? I can move the dragon, I can tell him to fly, I can spew fire, like that. I have other dragons going on. I have that fire meter there, the health bar. I have potions. So I have just a lot of different things here. So why am I showing this? Well, if we take a closer look on the code, we can see that it's split up in different packages. We've done that. It's split up in different classes. We've done that as well. We have an abstract class that implements an interface. We've done that as well. We have this class that overrides that abstract class. We've done that as well. We have enumerations that we use. We have enumerations that where's that? Let's see. We have enumerations that we use together with Enumerations sets to return multiple of these enumerations. We also have interfaces, and yes, everything that we've been talking about. We have, somewhere in this example we have generic classes, error handling, we have packages, classes, subclasses, abstract classes, interfaces, enumerations. So everything this course has been about, and the last course has been about as well, is inside this example here. But of course we have something more. We also have graphics, and the graphics part itself is not too tricky, but here's an example of what you can do with it. So I wanted to show you sort of when we learned all of these things, all of this of object-oriented programming, what can you use it for. So for instance, we have a abstract class called dragon, but then we can have a player dragon, which is the one I can control, which for instance controls the health bar up here and things like that, but it also is controlled by my keyboard, where the red dragons there are another subclass called enemy dragon, and they are just using a very simple AI. So this is an example of basically what we can do with what we've done, but the best part is not, I'm just not going to show this for you to be able to see, alright, yeah, that's what you can do. I'm showing this because the source code of this, like all of these 20 different files that we have here, are in a zip file uploaded to the lecture page. So if you wanted to continue with your Java, want to make something graphical, then download that, take a look on how it's done, make your own thing, or if you want to, just download that, see how it's done, poke around in the code to convert this to an actual game. Because at the moment it has the potential of a game, I guess, but it doesn't have an objective or anything. So just add more things, poke around, see what you can do. If you're not too sure about some, like, why would I use an abstract class, why would I use an interface, why would I use a enumeration, what would I use this for, why would I use subclasses, and so on. Take a look in the code. Of course there are quite a lot of code, but it should be commented fairly well, and lots of the code could be just alright, that thing does that thing. I don't know exactly how it's drawing that dragon. The dragon rendering code is quite advanced, but you don't need to know exactly that, but you can still see how the structure is built up and how things work. So I just wanted to show you that and give you the opportunity to poke around with some graphics, even though these courses have nothing to do with graphics whatsoever. So that's outside of this course, but I still wanted to show you this so you could do that. But that's all about those dragons. The code is on the lecture page after this lecture has been finished. So right, that's pretty much everything for now. We have the assignment as well, which is going to be released a few minutes after this lecture has been finished. It's going to be about making a deck class, so we can have a deck of cards, and then a few different players can use these cards to play a very simple game. But more info about that you can read in the PDF file that you can find on the lecture page. So let's see what we've learned about today, shall we? So it's a short summary. So we started with enumerations, and we could do it like this. So we have public enum armor type, and then we can define the different values that we have. So here we have helmet, chest, leggings, and boots, and then we can only have those values. We can't have any other values at all. So when we had the armor type defined with an integer, what we could do then is just give it another value. We gave it like 22, that's not a valid armor type. And what we could do as well was like, alright, I created with type 1, that's leggings, right? Oh no, that was chest. So we like used the wrong thing, and everything was just confusing. So here we go. Now we have an enumeration where we have helmet, chest, leggings, and boots, and then those are the only things that we can use, basically. And then what we have more is constructors. Remember that the constructor of the enumeration can't be public nor protected, but it can be private or the default value, as you can see here. So we don't have any modifier in front of armor type in the constructor there. And to do so, we when we have the constructor, we ask for parameters like any other constructor, and in this case we have int strike percentage, so that's an integer, and therefore when we have helmet, chest, leggings and boots there at the top, and remember you have to have them at the top, then we need to specify one integer each, and here we store them in strike percentage. In the code from the lecture we also had a method, but that didn't really fit in this slide here, and that method was public, so it's totally fine to have public methods. It's just not alright to have public constructors. You will have them as private or the default scope. So with this example here, we could use them like we always did, helmet, chest, leggings and boots, but we can also ask them for what's your strike percentage. Okay, so then we had enumeration sets or enum sets where we could give it different enumerations. So the first one there, we create an enum set with font styles bold and font styles italic. So we give it those two values, and then we can use that enum set so we can loop through and check which styles we have, for instance. But of course we can also get a enum set with all the different styles that we have. So then we do enum set all of, and then we do font styles.class. So remember that .class, that is necessary. And we also have the same thing, but for a completely empty set. So enum set none of font styles.class. So that will give us an empty set, and in this case that would represent a plain font. So in the font example we could give it bold, italics and underline and so on. So if we didn't give it any styles at all, then well, if we just be a plain font, a normal font. Okay, and then when we have that, we could check if we had a specific enumeration value as a part of the enum set. So here we do styles.contains, and then we give it the type like so. So styles.contains font styles.underline. We'll make sure in that if statement, if we want an underline, then we might want to draw that underline, or we might want to do something else entirely. But we can check if that value is a part of the enum set. So styles is an enum set of font styles. Then we had the try catches that we spoke about this part of the lecture. So you can just do try catch, and then you type which exception you want to catch, so file not found exception, and then we give it the variable name, so then we can refer to the error in this case by the name E. So I told the error to be called E, and then we run something specific code if an exception of this type was caught, and those are the three dots there below. So any code that we put in there will be run if any code in the code above there will cause an error of the correct type, or will throw an error. But of course we can have multiple catches. So here we have one catch which we will run if we didn't find a file, and another catch which we will run if we had an illegal state of something. So remember, if we closed our scanner, then if we try to read something from the closed scanner, then a illegal state exception would be thrown, and therefore we can run some code there that like, alright, you're silly, you're like closing stuff and printing things out in the wrong order, while the other error could say like, alright, you didn't find a file, please revise your file path, maybe it's wrong, blah blah blah. That was that one. But then of course we could pipe them together in the same catch. So this catch here is going to be run if we caught a file not found exception, or if we caught a illegal state exception. So it's just a pipe there, so we pipe them together, a vertical line there. So any of those, and then we can just run some code there. And then we finally have the try catch finally. So afterwards we have run the code in the try block, or if we run all the code in the catch block because we got an error in the try, we will run the code in the finally block there. And that's the case even if we try to break out from the catch or something like that, or break out from the try. Maybe we want to return a value after we're done, like, alright, we tried to generate the value and alright, it went alright, we return that value, and otherwise we might return null in the catch, for instance, but then in the final we could make sure that the scanner has been closed and everything, so it's being closed even if we caught an exception, and even if we didn't catch any exception at all. And we can also define a method as, we can define it that it will throw a file not exception, or that it can throw a final exception rather. And remember, if we call that type of method, we will have to make sure to catch that error in some way, that exception in some way. So that was what we had with the constructor of new scanner. So when we created a new scanner of and giving it a file, then that method, that constructor, was defined as throws file not found exception, and therefore we had to have a try catch around the part when we created the new scanner, or put it in a method where we also define it as throws file not found exception, but if so, we would have to have a try catch around when we call that method instead. Then we had the dragons, so that's just a possibility for you to see what you can do with all these things we have learned, all this object-oriented programming, and also get a foot into graphics as well. So of course the graphics is not part of this course, so this dragons example is not part of this course at all, but I wanted to give you an example of where you can go with this, what you can use object-oriented programming for. So you can just download the zip file on the lecture page, or file from the lecture page, and poke around, make something cool, make something silly, make something fun, make something weird. And if you do something that is worth sharing, I would love to see it. So just poke around, do what you want, take a look into graphics, see what you can use object-oriented programming for. So that's using everything that we've done in this course, and of course other things as well, like graphics. And finally, we have the questions and exercises document. So we have questions to see if you've learned what we've been talking about this lecture, which has been enumerations and error handling, of course. Exercises, so you can practice these two things as well. And further explorations. The further explorations in this case is, one, go ahead and make the assignment, and secondly, well, here you have the dragons game-ish thingy, do something fun with it. So they are a bit abstract this time. But we have the answers to the questions, so if you want to make sure that you answer them correctly, and a short description why that answer is correct. And finally, the possible solution to these exercises. So of course, when you write a program, you can write it in many different ways, but one solution will be included. But like I've said, the assignment will be released in a few minutes. I will just tell it to be uploaded properly, and then you can access it from the course page, and that will take you to the assignment page, where you can find and download the assignment as well as hand it in. And this, like I said, is going to be about a card game, so you write a deck card, a deck class and a card class, and so on. And if you manage to make a proper, write a program properly and send it in to me, and I say, all right, this is good, you have done everything that you're supposed to, then you pass the course. If it's not good, then I will send it back and say, all right, you're missing a few things here, please fix those, and then you can send them in back again, and do so till you pass the course. So right, this has been Thinking with Objects, lecture number 6, Enumeration and Error Handling, and I've been VSWE, and this has also been the whole course Thinking with Objects, which has been about object-oriented programming in Java, but it has also been the whole Java course series with the Thinking with Objects, the second one, and also the first, Coding and a Cup of Java. So we have gone through the basic of Java and the object-oriented in Java, and now if you want to continue with the courses, the next 4 coming courses are about Minecraft modding. So the next course that will start in a few days, called Forging a Minecraft Mod, will be about the basics about making a Minecraft mod. So if you're interested in that, I highly recommend you to join those lectures as well. But that's about it. I hope you enjoyed this lecture, this course, well, these 2 Java courses, and I hope to see you in the next course if that's something that you're interested in. Goodbye.